So I'm going to be talking this very long talk title about running a successful continuous delivery enablement team. Kind of a in the trenches experience report, and hopefully you can take away some things you might be able to put into practice in your workplaces. So with all this, context is everything, so some of this might be applicable. Hopefully you can go away with one or two things that you can put into practice tomorrow. So a bit of context. So this was for the most part of last year. I was working for a client. They were in the legal industry, and we were helping them get a new product into production that was basically aimed at lawyers, and it was a software as a service product. So think Google for lawyers, big search box, you're a lawyer, someone comes to you and says, I need to sue someone because their dog has dug up my garden, whatever. And you're like, I have no idea about that, they didn't teach us that. Law school, you Google it using this tool, and it shows you what the actual law is around that, but then also a bunch of other stuff like some flow diagrams for how would you actually interpret this law. Okay, I need to do this step. Did the dog weigh over this amount? Fine, then go and do this step, whatever. And it tells you how to interpret it. And there's millions and millions of digitized documents that they've processed over the years. So that's the product. It was live in the US. They wanted to put it live in the UK with just a few tweaks. You know how it is. So, and it wasn't going well. So it was a globally distributed development team. So we were in the London office, but there was developers in India, there were developers in the States, there was some QAs, there was architects, DevOps. We can go into that in a little bit. Big team, big enterprise development, and it was also going through a cloud migration at the same time. And just to give you an idea of the code, we ran some code quality metrics when we first landed. There we go. I mean, obviously those numbers the colors could mean anything, but let's assume we chose sensible defaults. So yeah, lots of code, 1.4 million lines of code. This was the bit the UK team was working on here, this little bit down here. It's a big system, big monolithic architecture. The architecture doesn't matter so much here, but just to give you a flavor of what we were working with. And importantly, these were the consequences. So, big ticket one at the top, 3 months to deploy a new feature. So that's from kind of code commit to getting it out the door. High defect rate, lots of rework there. Coupled release schedule, so kind of the anti-pattern of testing in a big integrated environment when you've got all your services together and you're testing them in one big box, and then when they finally work, you're like, well, whew, now we have to march those exact versions of those services in lockstep through to downstream environments because we only trust them working together as one big blob. And because of that, our old favorite code freezes there. So, branches that you're only allowed to do bug fixes on, and then you have to fill in a form to get the code committed to that branch and stuff. So lots of fun like that. Knowledge silos. So there were development teams all over the world. They didn't talk to each other. There were architects in the US who were meant to kind of set the direction. They didn't really talk to anyone, know what was going on. There was a standalone DevOps team, because of course there would be. And then we found another DevOps team in the UK who didn't know about the other DevOps team, so we introduced them to each other. It was like those novelizations, like the Phoenix Project, the kind of novelizations. I felt like we were living in one of those. It was quite exciting. So low team morale. Developers, at the end of the day, I'm a developer. I want to get the code that I write in front of customers. That's what we're in it for, right? That's the game. And when you're having to bash through bureaucracy and get snarled up in releases and having to fix bugs all the time, it's not a fun place to be. And the end one is really the killer, is they were losing in the marketplace. Their competitors could ship code quicker, get features out, respond to feedback quicker, and were moving away from them in the marketplace. So that was the key one. So that's a bit of context there. So what happened? So the client came to us, and we'd be working with them for a bit, and they said, well, we've heard about this continuous delivery thing. We think it could be useful for us. So we'd like you to do some of that, please. And they said, we'd like you to create a continuous delivery enablement team. We kind of ummed and ahed and went, oh, that's a bit of an anti-pattern, but it's an opportunity. So let's jump on it, because this might be the only chance we get. So in many organizations, this might be an anti-pattern. And hopefully you might not need to do this. But now I'm going to kind of walk you through what the team makeup was and all the things we learned on that team, some of which you can take away regardless of whether you've got a standalone team or not. So our team was about 5 developers to start with. So there was only like 2 of us dirty consultants, and then the other people came from the existing teams. We were really keen to have people who've been working on this system and knew its intricacies. So first learning, it's not about the tools. I can't stress that enough. I mean, I don't think this conference is great because so many of these talks, there's hardly been any there's been hardly any code and not much talk of tools, which is brilliant. But basically, when we landed and we said, right, we're the Continuous Delivery Enablement team, the kind of powers that be were like, okay, cool, so you're basically going to tell us what tools we should use, as if switching, so they were using Jenkins. They were like, well, tell us what we're going to replace Jenkins with, and then we can go on our merry way. What's the implementation plan? And we were basically said, no, tools cannot fix a broken culture. In fact, tools amplify your existing culture. I found this lovely slide in the internet. This is the kind of state of tooling within continuous delivery today. And I'm sure we've used a bunch of these, and they're probably all great for a certain job, but switching one out for another is not going to make the blindest bit of difference. So for the rest of the talk, it kind of focused, all the main learnings were around human behavior, not tooling. We needed to fix that first. So there were some cultural challenges, and these are the big ones, and these are the ones that are harder to change. Not proactively addressing problems. So things as simple as broken builds. The build would break. Oh, that was someone else over there in the big monolithic system. It was probably them. So you don't go and fix it. I'm sure we've all seen this. Resistance to change is another fun enterprise one. You might have heard the analogy of organizational antibodies. So organizations kind of will push change back almost by default, whether that's by slowly grinding you down by a series of forms and processes and meetings and so on. And often that happens because something in the past happened that was bad in an organization. Maybe something got pushed to production that shouldn't have gone. So you're fine. Okay, so the way to fix that is we put a bit of process around it. And then we get someone in whose role it is to make sure that process gets adhered to in the future so that the problem doesn't occur again. And then that person leaves, someone else comes in to replace them that keeps doing the role, even though they don't really know why they're doing it. So that role is that's now like a scar in your organization that's been solidified with roles and process. When you come in and try and change it, that person's going to be like, well, that's my job. You're taking away my responsibility. Even though when you actually step back, you say, well, what are you optimizing for here? What's the value you're trying to get out of this? It's quite hard to answer. So resistant change, breaking down silos. I mentioned before about all the silos. Knowledge was all in those bits. No one really knew. The developers didn't know how the builds were configured and that kind of stuff. Communication, people didn't really want to talk to each other, even though they were colleagues. This theme has come out in a bunch of other talks. Classic one, getting people to care and understanding the benefits of CD. To a lot of people, it's a buzzword. And why should they bother, right? What's in it for them? We're just coming in and moving their cheese and making their world more difficult. And it's kind of similar to some earlier ones, no sense of ownership, and people not empowered to affect change. People are very good at spotting problems and feeling the pain, but then it's the next step of actually saying, well, we're actually going to do something about it, instead of just kind of whining to your boss and hoping that something comes down and someone fixes it for you. So we kind of, halfway through, about 6 months into this, we did a finger in the air estimate and said, of all the work that we've been doing, how much of it has been technical, like actually at the keyboard, writing code, configuring things, and we reckoned it was about a quarter of the time, which meant 3/4 of the time it was essentially speaking to humans, which is the right thing to do, but just to that was how this thing played out. There were some capability challenges too. Writing good tests, we'll come on to that later. Lack of awareness of the test pyramid. There's Martin Fowler's lovely test pyramid. I don't want to go into too much detail, but lots of cheap running unit tests and a few maybe happy path, full stack, end-to-end ones at the top. Lack of CI tooling understandings. They used Jenkins, but it was a bit of a black box. No one really knew how it was configured and was scared to change it. And lack of cloud knowledge, moving to AWS. So the first thing that we did, we landed, instead of being like, right, well, read through the continuous delivery book, you need to do this, 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 and this. That's not going to work, because if you start just mandating stuff, people are going to push back. They're going to get defensive. The organizational antibodies are going to push you away. So we wanted to bring everyone together. And that's all the people who are working on this product day to day. So most of them were in the US, so we flew out there. And we said, right, let's have a workshop. Let's get everyone in the same place and let's talk through these problems. We were pretty confident of what things we could do to improve the situation, but we needed everyone to come to those conclusions together, not mandate it top down. So we ran through these workshops. So we kind of wanted to take a bottom-up approach, not top-down. We also sent out in advance, I blurred it to protect some names of the innocent, but we basically sent out CD readiness survey, which is essentially a survey to anyone who is technical in the organization and even product managers in those teams, with a bunch of questions along the lines of like, where do you think you are in terms of version control practices, how long it takes you to get stuff out into production, test coverage, that kind of stuff. And then people would send replies, and then we could just see where people thought they were, and you can kind of see from the red that people thought things weren't great. What was interesting is where you'd have two people in the same team with kind of slightly opposite views. Some people thought it was great, some people not so good, and typically the people who thought it was great were the tech leads or the architects, and then the developers would be like, nope, not so good. So what do we do in these workshops? So visualize the problem, and there have been some great talks earlier about this. There's one on event storming earlier, which I thought was great, and we took a similar approach. I learned about this technique a couple of years ago, and it's basically my go-to now, any project, which is kind of path to production mapping, which is basically what happens from a developer committing code to that code going out into production. What are all the steps, every single step, be it a manual step, be it an automated one, get them all down. And it's a fun exercise because you'll actually find out that often no one person or even one team will know all of those steps. They're like, oh, and then ops does something over here. Well, cool, let's get them in the room and get them to fill that bit in. So it starts people talking together. And you can use different color post-its and whatever to have different keys for stuff. So these are some of the examples of the teams. This one was our team, so I brought this over in my suitcase from the UK. This is path to dev, not path to prod. Path to the first integrated environment. It kind of snakes around here because we ran out of room. And at the top, for a bit of bonus work, we turned it into a value stream map, so you can see of these activities which ones actually add value and which ones are queuing time. You can't read it, but this, we totaled up the time, 75 hours from commit to the first dev environment. So that's kind of what we're dealing with. Hopefully you might not be in that kind of place. But yeah, so things were pretty bad. There's another example from another team. But it was the people in the teams doing this. The next step, once you've got those path to productions, is to put all the pain points on. So you see a bunch of pink stickies have appeared everywhere. So those are your pain points. You also add the timings at this point. So for every step, you say, how long does this take? Whether it's queue time, so when you're waiting for something to happen, maybe you're waiting for a build agent to be available or waiting for someone to action a pull request. Or if it is running the test, how long does it take to run the test? So those pain points are easy to establish because if something takes a long time, it's a pain point. But then there are other types of pain points. Some of them are manual processes, so that's a pain. Some of them are risky, like, oh, you know, this you have to enter like a manual release key, and if you get it wrong, you accidentally deploy to the production in the United States instead of the UK. Ask me how I know about that one. And other things, yeah, to do with maybe these tests are brittle and they are flaky and they fail every so often, that kind of stuff. Get all those pain points out, smatter them around. So I'm not going to go too much into what we discovered, but it was all the classic stuff that we kind of knew about in advance. You know, there was lots of manual steps, lots of waste due to high queue times, handoffs between teams. I mean, some team was particularly bad, like they couldn't even run their own tests. They had to email another team to run the tests. I've never seen that before, but this highlighted all those issues. Lots of other things, you know, like not building your binaries once, but I don't want to go into the technical details. Yours will be different. But anyway, we then kind of take a step back and say, well, let's forget all the constraints that we have. What would your ideal path to production be like? You stay in those teams, but you make sure you've seeded into those teams some people who understand continuous delivery and the benefits. You can kind of suggest, like, well, how about we only just built the thing once and then just deployed that? And people generally quite receptive, like, oh yeah, that would make sense. So this is quite nice because it's a bit of blue sky thinking, frees you from the shackles of your current world, and obviously they look a lot simpler, and then you can kind of put them next to each other and say, right, this is what we could be shooting for here. How are we going to get there? Anyway, so then you go back to the world that you're currently living in, and you basically take all the pink stickies off, and you say, well, these are our problems, and then within the team, you vote on which you think the top 5 are, so you know, get 3 votes each or whatever. They are your top 3 problems. Forget the others for now. You've got to focus on a smaller set, because the sooner you can start fixing them, the sooner you can see feedback, and the sooner you're like, this is good, we're going to do it again and again and again. So you vote on them, and then go through and come up with potential solutions, which actually isn't that hard, because often a lot of these will just be, you know, read the continuous delivery book for the most part. But the good thing about this is, even though these solutions, to be honest, we could have come up with these at the start, but if we'd have come in and told them, you need to do this, it wouldn't have happened. Whereas there was a sense of ownership, because all the people who feel this pain and be the ones involved in fixing it had been involved in coming up with the solutions and felt they'd taken part through that entire process. And that's key, that kind of buy-in and sense of ownership. So it could go into the backlogs of the teams and their assigned owners, and we moved on. So some of those bits of work were kind of cross-team, and so our standalone CD enablement team took those. So the first thing we learned was within our CD enablement team is we need to have clear and visible goals. So a lot of people, and this has come up in other talks, don't really understand continuous delivery still. They think it's something to do with automating stuff or pushing to production all the time automatically, and it's really scary. So loads of people will come up to you and be like, what are you doing? Or they'll misunderstand what you're doing. So it's really good to have a mission statement. Like in any product team, it's really good to have a kind of elevator pitch. We are doing this, and these are the benefits. So we quickly learned that was important, so we wrote one up, and this is ours, word for word. Our high-level goal is to enable teams to deliver features faster and with higher quality. Who wouldn't want that? And importantly, we wanted to put ourselves on the hook for some metrics. We wanted to make it measurable that we were having an impact. So we have an initial 8 weeks to improve the following metrics. So we were measuring ourselves based on time taken per successful deployment, absolute number of successful deployments per day, time taken to fix a failing deployment, which is kind of mean time to recovery, and time from code commit to deployment. So that's kind of cycle time. These last two are kind of the key ones here. And there's no surprise. We didn't make these up. We basically went on the State of DevOps report, which I'm going to talk about a little bit coming up, and basically said, what are the indicators of a healthy IT organization? Oh, it's these, fine, let's put ourselves on the hook for these. So we basically backed ourselves and said, we're going to improve these. And the good thing about this was, as well as indicating what we were doing, it was just as useful to say what we were not doing, because a lot of people misunderstood what we were doing and thought we were like an automation team, and they'd come up and be like, oh, can you create yet another integration environment, please? And we'd be like, instead of just being like, no, that's not in the continuous delivery book, we could be like, no, well, we've agreed on these metrics. Will it move the dial on any of them? No. Okay, then I'm sorry, but it's not a priority. So it allowed us to push back, but backed up by metrics. Next one is run as a proper team. So what we could have done, and what I've seen happen in other places, is we could have said, well, we're doing continuous delivery, and then lock ourselves away in a room and start mashing on the keyboards, and people would walk by and be like, what are they doing in there? Oh, they're doing some, impressive continuous delivery stuff. Better leave them to it. That is super dangerous, because then we just become another silo, and that's really bad. And then we go, and then it's even worse than before. So we wanted to run as a proper team. And what I mean by that is kind of work in the open. And be really clear about what you're doing and allow people to have input into your team. So this was our Kanban board, which is just right up. We were next to all the other teams. We split our work down into stories, as you would hopefully on a normal team. We reprioritized them. And importantly, every story had an accompanying hypothesis. So we believe that by doing this bit of work, maybe by automating this particular step or whatever it was, we believe that it will improve this metric or these metrics. And they had to be the ones we talked about earlier. And so that was your hypothesis, and that really allows you to prioritize, right? And then it allows you to measure whether what you've done has actually had an impact. So getting that feedback loop in pretty soon, and that really helped us prioritize stuff, because there would be years of work here, and how do you know if what you've done is actually having an impact? So run it as you would kind of like a normal product team. We had a full-time team. We didn't have any people doing 50% time. And also we cycled developers from other team. We had a rota system, and they would come and join us for 2 weeks and pair on stuff with us. That way everyone could get exposure to the work we were doing, and we would really try and make ourselves kind of redundant by spreading all that knowledge. We had showcases every 2 weeks where we talked about what we'd done. We recorded demos. We really tried to be open, and we had retrospectives as well, and so on. Slight digression here, but this tripped us up early. And so this is not a continuous integration conference, right? It's continuous delivery, but you can't have continuous delivery without continuous integration. And lots of companies and places say, oh yeah, of course we do it. But having a CI tool does not mean you're practicing continuous integration. So another quick Martin Fowler reference, this is his test. And it's surprising how many places fail this test. I've been in places, hands in the air, that have failed it. Every developer commits at least daily to the shared mainline, so daily. So if you have practiced pull requests, which is fine, but if you have a pull request that goes longer than a day before being merged in, you're not practicing continuous integration. You're not continuously integrating. Every commit triggers an automated build and test. Hopefully we're mostly doing that. And then the other one that trips you up is basically if the build fails, it's repaired within 10 minutes. So they weren't doing that, so we kind of needed to target that first. So an example of why this was breaking down is to get code through to the first development environment, integrated environment, you had to get a pull request approved. Now the pull request could only be approved by the architects in the States. And if you got unlucky and put your pull request in at a certain time of day, they wouldn't pick it up till their next day, And so you could often be waiting longer than a day just for someone to be like, yes, okay. And so that means it wasn't integrating at least daily. It wasn't achievable. So we said, well, okay, how about some people in the same time zone have permissions to put the pull requests in? And they kind of said, and said, yep, okay, they were trusted people. And then suddenly, in doing that, they were sitting next to you, so you could just go, I'll put a pull request in, but can you just come over to my desk and review it? You do it, and then, within 10, 20 minutes. So we cut the cycle time by 24 hours with 0 technical changes, just by some process ones. And this I've alluded to already. Be on the hook for metrics and having hypotheses, make data-driven decisions, like you would do in a normal product. Otherwise, you're basically just chucking features or whatever out into the void. You want to measure what we do. So I've got a couple of examples. The first is the UI test suite audit. So I talked about the test pyramid earlier, which is kind of what you're shooting for. The shape of the test here was kind of like a capital letter T, where you've got nothing, not much, a few unit tests, nothing, and then a massive load of Selenium tests. So testing through the browser that tested the full integrated, all the services and everything. I'm sure some of you have been here before. What that means is those tests are brittle, they fail all the time. If they fail, it could be one of 1.4 million lines of code. It's really hard to work out what's going on. And that means that it's pretty much impossible that they will all pass at the same time. And so the results get ignored because otherwise nothing goes through. And so then things break and you never know about it. We knew right from the start these offered little value. But if you go into an organization and say, those tests that you've been working on for one and a half years that you've sunk a lot of cost into, we think you should delete them all, really. We think you should declare bankruptcy. That's going to have pushback, so you need to prove it with data. So we wrote some scripts that grabbed them all from Jenkins, and these are results. So I'll summarize very briefly. There are about 600 and something Selenium tests. Each one took 51 seconds. We talk about 10 hours in total. Sometimes it went up to 12 or 13 hours just to run the test suite. What that meant is you could only run the tests on a schedule every once or twice a day, because you couldn't do on-commit test runs because it would just clobber the existing tests that are running. And we measured the stability. So basically, the unstable ones here are the ones that on an average, on 10 runs, passed or failed. And so we could prove from this data that the tests were offering 0 value and should be deleted. And so we did. There were more problems that came back then when we kind of got rid of them, wrote a nice test framework to people build on top of, and then they proceeded to start rewriting the 632 again, which of course would happen because it's the culture. So we had to start running workshops and so on to help them break down a Selenium test into some integration tests and unit tests and so on. This is the thing I'm most proud of. So this is a shout out to Steve Smith and his measuring continuous delivery. We're on the hook for metrics. We need to measure those metrics. So instead of having some scripts that we just run randomly, we're like, let's just build a dashboard and have it there so we can just reference what the state of play is. So we just basically scraped a bunch of stuff from Jenkins. It was a bit complicated because of the build process. There were like packages that the teams built that got integrated into the compile time, so we had to kind of trace backwards to work out what commits went into a build. Hopefully your system might be a bit simpler. But this was great. So basically, I'll quickly whiz through what's going on. This is your code commit to deployment time at the top. So this is time going by, and this is how many days it took for that code to go in. You've got the current value, so at the minute this is on about 8 days, and whether it's improving. If it's green, it's improving. If it's red, it's getting worse. And here is a kind of what parts of your pipeline are taking up the most time, so it shows you what you need to attack next. Here are some stats around how many absolute deployments per day, stuff like that, and the stuff at the bottom is mean time to recovery. So basically, as soon as a pipeline fails, the clock starts ticking, and when it goes green again, that's your measurement, and you plot that. So everyone says, what's with this big spike here? So this, for those of you who can't see, this scale on the left is in days, and it goes up to 347 days. So basically, some code got committed that had been written best part of a year ago, and they'd never made it into production until that point, and we wouldn't have known about it for this. And we were like, oh, there must be a bug in our calculations here. No, that's really what happened, because someone had basically published a package and it hadn't got integrated in later. Think of the horrific risk around that. I mean, most of the team probably don't even work there anymore if there was a bug in that package. So yeah, this was great. And what this allows you to do is then basically start a propaganda war where you go and get all the HDMI cables and all the spare laptops, and you smatter it up around the office. We put old laptops, we commandeered the TVs that had nothing on, And suddenly people started talking about this stuff. What's that? Why is there a big spike over there? Oh, does it really take us that long to get our stuff into production? And so this is great. You can go to, this is a really great conversation piece with product managers and tell them this is why we need to focus. You need to allow your team to work on this continuous delivery stuff because this is the current state of play. And you'll be able to see an improvement, right? We're going to predict that this graph is going to go down. So this was a really powerful thing to do. And these are results after the first 8 weeks. So time from code commit to deployment went down to 5 days. Pipeline runs per day went up from 1 to 7. I mean, these still aren't great numbers, right? But the point is it's baby steps. Pipeline run duration went from 10 hours to 15 minutes. That's what happens when you delete all the Selenium tests. And this is my favorite. The mean time to recovery went up like infinite because, so I'm not making this up, there had never been a green build. That's what happens when you have 600 and something Selenium tests. So hopefully you're not in that situation. But there was a green build for the first time, and that was cause for celebration. So it's still 23 hours. I mean, it's not great, but it's moving in the right direction, and so this makes a powerful message. You don't want to be a silo. You want to make yourselves redundant, right? So what do we do about that? The first is give the teams the capability to improve themselves instead of always having to tell them what to do. So buy the continuous delivery book. I mean, he's here tonight, Dave Farley, right? So buy loads of copies, smatter them around, download the State of DevOps report, which is an amazing survey if you haven't seen it, which is basically lots of statistical analysis around practices that teams do and the correlation between that and high-performing IT organizations. Before you hire a bunch of expensive consultants, and I'm saying this as a previous consultant, just get this stuff. It's nothing. It's peanuts. And give your teams the time to read it and come up with some solutions on their own. They're at the coalface. They know the most about how to improve their situation. You just need to give them the time and trust them. They're smart. You hired them because they're smart and they're good at getting stuff done. So give them the capability instead of getting someone in to tell them. Another good example is pipeline changes. So we needed to build a pipeline because it didn't really exist before. I'm not going to go into the technical details, but what we did is switch from the pointy, clicky, GUI stuff to the new Jenkins pipeline as code, which is good for some technical reasons. But what is nice is that suddenly the teams had ownership. The code was living in the same repositories that they worked in day to day. It suddenly wasn't so scary. We could pair with them. We could do some mob programming sessions, sit with them and help them build their pipeline. And then they could start adding to it over time because they felt they owned it. So this was a kind of lovely side effect that isn't normally talked about when you see why pipelines as code is good. So it really encouraged collaboration and meant that we didn't want to be the team that owned the pipelines. That's really, really bad. Over-communicate. So we wanted everyone to know what we're doing. Nothing should be in secret. So we had regular showcases. We broadcasted our work explicitly. So if you can't see it, this is an explicit column we put on our Kanban board right from the start, which is broadcast. So after something was technically done, it moved into broadcast, and which basically meant it depended on what kind of story was. How do we make sure people know what we've done and we won't have to be the ones who do it again, that they can take this forward? And it totally depended on what story it was, but we would do demos, mob programming in person, feedback, get it from people, put it on the wiki, all that kind of stuff. So there's a cost to this, right? It's going to hit your velocity, but it's the right thing to do. So that made us always consider broadcasting. And lastly, there are going to be some things that just you can't fix. They're not within your bounds of responsibility, but they're glass ceilings and they're going to impact you. So just because you can't directly affect them, you can use what you've learned, and especially the data that you've got, to advocate for changes that other people can take forward. So the example I'm going to give is the microservices experiment we did. So I talked at the beginning, big monolith, right? So we could have gone in as consultants and gone microservices, microservices, microservices. And they would have probably said, oh, that's a buzzword. No thanks. And they probably would have been right to do so. But having worked in this for a while, we gathered this all this data, and we could show how long things were taking. We could go to the architects and the CTO and say, we have a hypothesis, which is if you take a particular bit of functionality, and here's a team that will be a good candidate, and you split out their domain into a separate service, which is integrated with the main monolith, but they can deploy independently. Our hypothesis is they can get stuff out into production much, much quicker than we can now. And they were like, okay, cool, let's do it. So we did it as an experiment, and we didn't do it, but we helped them make that argument, and then they went to it. Our dashboard could just plug in to their repository, so they got all the metrics out the box, and so then you could compare apples with apples. Guess what? They could deploy to downstream environments in minutes as opposed to days, so orders of magnitude quicker, but that was backed up with evidence, not by us just having some kind of mantra that some architectural style would be better than others. So that is if it's continuing. We did a similar thing with contract testing, but I'm not going to go into. But again, we had some data, we gathered it, and then we could have a hypothesis and have a sensible conversation around that. Having conversations around data takes emotion out of it. It doesn't become between people. You're talking about something which has no emotions, and that makes it a lot easier to have those kind of conversations. And lastly, sometimes you just have to do the right thing. We're well-paid professionals. We've been paid to do a job. We want our companies to win. Sometimes you just have to do the right thing. Seeking forgiveness over permission is a good mantra that often you have to do. But if you've got this kind of data and the metrics, you can justify your actions. You're not saying we're just doing this because Jez Humble says it's the right thing to do. You can do it because you say, look, we've got data here around it, and we can see that we have a hypothesis that it will have some good effects. So you're going to break stuff. We broke deployments a bunch of times. We deployed stuff to the US by accident, and it happens. And then you put your hand up and you say, yep, that's us, and you kind of embrace that fact and own up and kind of be an example of how it should be. So yeah, break it, fix it.